All right, we have 8.6, identify special quadrilaterals. This is the last section in chapter 8, and if you look quick, it's just front and back page, so it seems pretty short. Now, I do have some extra information I want to make sure I give you, but we'll keep it here. What this really is focusing on is we've learned a lot of different properties of different quadrilaterals. We had all our parallelograms, all our rhombuses, all our rectangles, all our squares, and then we went into the trapezoids and kites. So this is saying if I group them all together, what should I be able to do? Okay, what do I know about these? So this is kind of going with here. Now, this section really goes with that gold note page we're going to do, or already did. I don't know where we're at in the progression of things there. Really sorting through the different properties of different things, okay? So this first one says, a quadrilateral ABCD has both pairs of opposite sides congruent. What types of quadrilateral meet this condition? We're looking for possibly more than one answer. So I want to figure out any of my quadrilaterals where opposite sides are congruent. Well, if I think about my opposite sides congruent, that was a property way back with parallelograms, okay? So that means all my parallelograms have opposite sides congruent, okay? So parallelograms was the big idea, right? Opposite sides are congruent. And then I had the special parallelogram, so everything under that on our chart. So that means that rectangles fit that. That means that rhombuses fit that. And that means that squares fit that. So because we know that that's a rule for parallelograms, everything that's a parallelogram has that same property, okay? So all of those have opposite sides congruent. I know on a rhombus and square, all sides are congruent, but that also fits the rule of opposite sides are congruent. All right, number one here says right away, quadrilateral JKLM has both pairs of opposite angles congruent. So we have a four-sided figure, opposite angles are congruent. Well, what would that fit under? Well, if I think of opposites angles congruent, I wrote that down once again up on that parallelogram list, okay? So every parallelogram has opposite angles congruent and everything that is a parallelogram. So that means that's true for a rectangle, that means it's true for a rhombus, and that means it's true for a square. So everything there has that property. When I think about my other columns, the trapezoids, opposite angles are not necessarily congruent. In fact, they're never. And on our kite, only one pair of opposite angles are congruent, so I can't go to those, okay? And everything else in that is just the generic four-sided figure, and we don't know about their angles specifically. All right, last question on the bottom of this page, it says, what is the most specific name? So if you think about our chart, the one the farthest down on the list for quadrilateral ABCD. Okay, so when I look at over here, four sides, definitely. Okay, so I go to the next thing. The other thing I notice is that opposite sides are congruent. So if my opposite sides here are congruent, I know it has to be, let's see. So both pairs of opposite sides are congruent. Well, actually, all of them are, right? So ABC could be a rhombus because all the sides are congruent. But I have to always say, a rhombus is a pretty specific name, but there's one more specific than that, and that's the square. Is this a square? I mean, could this be a square? I'm going to be honest, it almost looks like one. But this is so important. If they don't give us information about the angles, they didn't mark them, they didn't tell me anything, I cannot assume anything. So because of that, I don't know if it's a square or not. So the best name I can give this one right now is a rhombus because I don't know about those angles. So go as far down that list as you can to give the answer, but if you don't know something specific, never ever assume, okay? All right, go to our second page here. And it says, is there enough information given this diagram to show this quadrilateral is an isosceles trapezoid? Okay, isosceles could be the key word here. Do we know that it's a trapezoid? Okay, there's nothing marked as far as parallel or anything. Remember, trapezoids have one pair of parallel sides. Okay, so they gave me three angles. I should probably find that fourth one. So let's do 102 plus 102 plus 78 plus I don't know what on x equals 360. When we solve for that, where's my calculator? 102 plus 102 plus 78, that's 282 plus x equals 360. Subtract that 282 from 360, and I do get a 78. Okay, so I definitely have some matching numbers here. I think the key thing I need to figure out, though, is if I add these two together, I get 204. So, okay, that doesn't really help me any. But if I add these two together, 102 plus 78, that equals 180. Well, remember, if two angles that are consecutive equals 180, it means they're between parallel lines. They're consecutive interiors. So, because G and H are supplementary, and F and G are not, we know there's one parallel side, so we know FG is parallel to JH, but FJ is not parallel, right? That not parallel there, I'll put a not in there to double do that. Not parallel is an oxymoron there, not gonna help me. So let me just put the word parallel so we read it. If it's not parallel to GH, so then by definition, because one pair is parallel, the other pair is not, we know we have a trapezoid. All right, now the question is, was it isosceles? So we're trying to see if it's isosceles. Well, we figured out that bottom angle was 78. What is the rule for when matching base angles? If base angles are matching, then we know that we do have a congruent sides. So a pair of congruent base angles makes it isosceles, right? So again, we check our rules on that, and we know we have that isosceles trapezoid. Okay, number 2 down here. What's the most specific name I can give that quadrilateral QRST? Well, let's see. Angles aren't marked anywhere. Opposite sides are not congruent. Oh, wait. 7 is congruent to 7, and 8 is congruent to 8. I do have some congruent. Oh, consecutive sides are congruent. Which shape has consecutive sides congruent? Kite, right? So if I have two pairs of consecutive sides congruent, I know I have that kite. So it fits that rule. Okay. For number 3 down here, is there enough information to say that that quadrilateral has to be a rectangle? Well, they only marked 3 angles. Oh, wait, they're all 90. If I do 3 times 90 plus my missing equals 360, that should be a 90, not a 9. Okay, so that gives me 270 plus x equals 360. Divide by, or subtract 270. Sorry, can't talk today. Oh, it's going to be a 90. So no, there's no way it's anything else. It's got to be 90. Is this enough to prove that this quadrilateral is a rectangle? Well, one of the rules of rectangles is I need 4 90-degree angles, and I definitely see 4 90-degree angles, so I would say yes, it has to be a rectangle because it fits that. Okay? All right, now, I know we finished what's there, but I'm going to fill this margin, okay? I want to do something a little bit more to kind of explain things and help us with our homework and what's some questions that are going to be on the test, okay? So just coming to the top of this margin, because it's nice and open right now, we're going to fill this thing. Remember in geometry, we put a lot of things on graphs, okay? So on a graph, how can you prove different shapes, okay? Quadrilaterals, that's what we're focusing on right now. So we have these different quadrilaterals. How can we prove that the one we have is the shape we think it is? Because I need you to do that mathematically. We did this a little bit back on our quiz when we were proving if something was a parallelogram. So let's start with, obviously a quadrilateral is 4-sided. We don't have to really prove anything. We're going to see 4 sides. That's pretty obvious. But what if we think it's a parallelogram? What is some math we can do to prove it's a parallelogram? Okay, we actually had this back in 8.3 notes. I'm going to be honest, go for the easiest, the most direct. I would tell you probably just find or count 4 slopes and make sure that the opposite slopes are congruent, okay? If you have that, you can say, I have a parallelogram, and the reason you can say is opposite sides are parallel, right? That's what it's going to prove is opposite sides are parallel. Okay, so we have these different parallelograms we want to make sure we can find. Okay, so what if you think what is on your graph is a rhombus? Okay, What I would suggest, because by definition, a rhombus has 4 sides that are equal, I would find 4 distance formulas. Okay, if you find those 4 lengths and all are congruent, then you can prove you have a rhombus. Okay? Our next one was a rectangle. How can I prove that I have a rectangle on a graph? Okay? Well, we're going to kind of go back to that parallelogram. What's special about a rectangle is those 4 right angles. How can I prove a right angle? Well, that same way we did parallelogram. We're going to go for 4 slopes, okay? We can count them. We can use the distance formula, whichever one you need to do. And what we want are 2 pairs of opposite reciprocal slopes. Because what that will prove is that we have those 90-degree angles. Remember, opposite reciprocal slopes comes from those perpendicular lines. And if we can get opposite reciprocal slopes, we're saying, okay, then that's perpendicular, that has to be a right angle. Okay, those 2 are perpendicular, that has to be a right angle. And if we can get all of those into those right angles, we know we have a rectangle, okay? Remember, in all of this, I won't accept because it looks like it. We need to prove it with some math, okay? All right, we have a square. What if we think what is on our graph is a square? What do we need to prove that? We're going to get 4 slopes. And of my 4 slopes, I want those opposite reciprocals, just like I did for the rectangle, because it's a rectangle. And, unfortunately, I need 4 distance formulas to prove that I have 4 congruent sides, okay? So I want 4 that are all the same. All right, we have 2 more shapes we need to talk about here. What if we think what we have is a trapezoid? If you think you have a trapezoid, we want 4 slopes again, okay? We want 2 equal and 2 not equal, if that makes sense, okay? If we think it's isosceles, okay, you need 2 distance formulas, and be careful here. On the legs, we don't want to do the bases because it won't help us, and we want them to be congruent, okay? And we have one more shape. What if we think it is a kite? If we think it's a kite, the best way to prove that is going to be 4 distance formulas, okay? And we need consecutive ones to be congruent, 2 consecutive to be congruent. We don't want opposite ones to be congruent, we want the consecutive, okay? So that's the math you're gonna do if you do that. Now, you have a couple of these problems on your homework tonight, okay? On that homework worksheet, you need to make sure that you are showing the proper work to tell me that you know that something is one of these shapes, okay? So for number 15 and 16 on your homework, I need to see some of this math work, okay? You can grab a graph paper, you can graph it, but I need to see some of this math work to say, yes, you actually tried this, okay? If you have questions, let me know.